All right. We can hear each other. Can we see each other? I hope so. Well, today we're going to be unpacking how we can activate the circular economy, navigating the risks and technologies and challenges, and I think we've heard some of those already. We're going to start from some questions from me to the panel, but again, we'd really like to hear from you, and there's going to be time to do that before the next break. So let's start with you, Jacken. If you're ready. We won't get to a circular economy without technology. So what are some of the examples of how technology is enabling circular economy in Korea?
We'll
just get some help with you. Oh, that's better.
Okay.
Yeah.
So as I mentioned, so I would like to, with the technology, to firstly define the definitions. So not all technology is knowledge. Not all the knowledge is not technology, but all the technology is knowledge. Knowledge, I believe, is a conditions for us to know something. So with the condition, we can give them the interest. Interest. I'm not English person's native speaker, but interest. You have inter and superlative. The forms of that. So we have the gap. That's why we have interest. So we don't. Without any gap, so we don't have any interest at all. So that's why. So we propose some interested the value, the newly developed. So to be able to form from our solidarity. So then they start to be interested. That's why. But the people in general, normally they are actually confused. So why we have accepted this one, and the other person asks me always the one token. One unit of a token is corresponding to how much dollar we can have. So that's the general response from that. But we slowly implement it. We just start our communication with this type alternative types of the money. Then we slowly understand what kind of value we can get, and we can get different types of knowledge and technology as well.
And what role do you think or opportunities are there for AI in the circular economy?
Okay. So big data is a resource, I believe, but the AI is the memory. So we have a memory, but the AI is also memory to be able to extract some valuable knowledge and technology out of that big data. So the AI is not our competitor, but our company, I believe. So that's the understanding of our team, our science world and team.
And do you think also, you talked about collaboration in your presentation, and how we need to take a new approach in terms of collaborating and providing incentives. Do you want to dive a bit deeper into that and explain, perhaps AI has a role there too?
Okay, so the collaboration between the science and engineer and humanity and artists is almost impossible. So we have a different language, I believe. So then as well as, that's why we developed language that we believe, and also we would like to make a place inside in it. We can everyday life base we collect in the morning and to share some coffee. So that's why in my campus we built a science cabin. So if you visit Korea and Ulsan city, and please drop by at this site, we still evaluate. And inside in it we have a toilet, and toilet connected to engineering building connected to our everyday the lives. So we drop the poo and transfer to engineering lab. Engineering lab converted into energy methane that we cook in living labs. So all the things every day, our behavior is a unit of our activity, and through those understanding we can develop a new language between anthropologists and psychology and societal person and engineer as well. So that's our learning from our activity.
Well, thank you, and I think there's a lot more to talk about there, but we might come back to you, Jack, and thank you for that. I want to go to Lou, and just ask you, circular economy is really needed to cut those carbon emissions. I mean, I mentioned it before, but it often shocks people how many carbon emissions are going to be left once we do that sort of obvious renewable energy transition. And I also was really surprised to hear your comments in the research you referenced that the water sector and the wastewater sector could be a huge contributor and opportunity for carbon abatement. I'm sure many utilities here would know that's the case, but for me, I didn't realise it was so high. Can you talk about that opportunity and also a bit more about the challenges there for the water sector?
Thanks. Can you hear me?
Pass this down.
Doesn't work. Thanks. Definitely, I think there are challenges, as mentioned, especially with the fugitive emissions, because it's coming from all different units and also with very dynamic emissions as well. So I think currently facing water sectors is how do we reduce emissions and then in the meantime achieve the circular economy. So some opportunities like lower hanging fruit, for example, as mentioned about the leakage of methane, that's something you can start to look at with your currently any of the digesters you're generating the biogas. Do you have any leakage? So if it's just from the fittings, the connections, you just replace with those pipings, and then you can reduce the leakage. And then with the pressure relief valve, you have to wait. I guess you have to wait until a new standard come out to see how we can solve that issues. But some of the utilities already to think to replace the floating type of the roof with that type of digester. If you're going to build a new thing, you probably don't want to choose this floating roof type of digesters. Then you can better capture those. So these are relatively low-hanging fruit. Then the other things will be, for example, anything you use chemicals that do have embedded, use fossil carbon generated chemicals. For example, I mentioned about the methane. I do know some of the European companies now try to produce the biomethanol, which is coming from the biogenic carbon generated biomethane, and use that as a carbon source. That's also something can be used to reduce the direct emissions. Then bigger challenges really with the nitrous oxide, which is a big topic and also focusing for the past decade. But there are also already some good knowledge bases. So if you really would like to tackling with that, so start with some monitoring to see how much nitrous oxide you're currently generating. And of course, if you are taking more nitrogen into your plant, you can also thinking how to better manage those nitrogen coming in. So either through the trade waste, I don't know if that's what utilities probably have to talk with other industry sectors to better manage with trade waste. But if you do biogas generation and taking additional food waste, you can consider, are there any relatively low in protein or nitrogen that you can try to consider to take, rather than take too much with this nitrogen embedded. So I think those are some, there are challenges, but also opportunities for utilities start to look at.
Keep the microphone. I think people can probably hear me. I'll speak loudly. You mentioned standards, and that's something close to my heart, because as we evolve and change and new technologies, we really need the regulatory environment to support it. And you said that there'll be new standards coming. Can you just lean into that a bit and explain, what can that look like to enable more circular economy activity in the water industry?
Okay, for the standards, I'm not quite sure what are the standards for the circular economy, but for the greenhouse gas side, we do considering to have a standard. For example, how do we monitor, how do we detect or quantify to define how much you emitted. So Australia, I think we don't have any leakage detection standard yet. Also with the NINGAS, we don't have a method written in our greenhouse gas energy reporting guidelines. How do we really quantify those emissions? But currently I'm leading an international group where we are developing a protocol. Hopefully later on will become a standard. That is how do we quantify the greenhouse gas emissions from the treatment plant. But for circular economy, I believe probably other panel members can comment more about standards related to their field.
Just to wrap up, Luke, can I ask you to then, what are those key actions not just for water utilities, but also for the sector? What are those priority actions then that we need to be focusing on for net zero in the sector?
I think currently action is that's about my topic. I want people to revisit the currently technology you are developing or the technology you are going to adopt, whether those will, or did you ignore the currently greenhouse gas part when you try to adopt those technologies or try to develop those technologies? Are there any associated risk that may generate more emissions when you adopt those technology, when you try to achieve? So either with scope 2, with energy, or with scope 1 potentially, or with scope 3, any chemicals. I think that's something I would like to call for people. Don't ignore that we try to achieve circular economy, but in the meantime, we do not want to generate more greenhouse gas when we try to adopt those technology to our existing facilities or for our future new development.
And what about mandatory disclosure of scope 3, for example? What impact could that have?
Okay, well, scope 3, because too broad. It's very, very broad. So I'm probably not the best person to talk about scope 3, and believe many people have a lot of experience. I think there are a lot of good movement in terms of scope 3. For example, I know with the embedded cement, like when we try to choose the cement to build new plants, there are different types. I know people or utilities or other who try to build new facilities, for example, for digesters, you can already select those ones that have lower CO2 sort of embedded emissions, like more green type of cement. So that's a choice, but that helps to reduce sort of these emissions already.
Terrific. Well, thank you very much. We're going to move to Bernadette. I'm going to get my mic back. Hopefully mine works. And it gives a go, does it?
Testing.
It does.
So Bernadette, we've heard about technologies and approaches needed to operationalise a circular economy, but when we start to collect a lot of these waste streams in a different way, we want to process them, we want to do different things with them. You know, what are the risks and environmental impacts, and how do we do this safely? How do we do this transition safely?
I think we take a lot of learnings from those countries who are doing it well, and I would like to point out that, you know, circular economy that is working well has been really, I think, demonstrated successfully in the EU. And if we think about the history behind what they've been doing, you know, they put out a very ambitious plan as early as 2015. And I think, you know, by the time it was around 2018, it actually had met some of those things, to the point in 2020, out came the Green Deal. And that is a framework which a lot of the EU have established a circular economy, and that de-risks a lot of what those technologies are going forward. But if we even look back further, there's the landfill directive. Australia, we've got plenty of space, unfortunately, and until we actually ban landfill, that's when we're going to have issues. And so that directive of 2018, I think, is going to, you know, create even more ambitious. But aside from that, you know, Australia, we're looking at minimising the risks and some of those unintended consequences that can come about from actually implementing the circular economy. But if I can talk through, you know, I think you talked about standards. The composting industry, you know, very established in Australia because it has a standard. But if you look toward land application of digestate, that's a different kettle of fish altogether. And it doesn't help when you've got different jurisdictions placing different things like that. But if you look at even biosolids, the reason why they're land applied is because it has an end of waste code, and that allows them to. And biosolids will continue to be land applied until there is, I guess, a new technology that might come about. We understand, you know, there are emerging contaminants like PFAS, PFOS, microplastics, but also heavy metals, and we're not quite sure, you know, what's the future of that. So we need to manage that. And in fact, that's one of the key areas that we are contributing in the ARC NICE Hub, working with Pyrocal and Logan, is the first demonstration of carbonisation technology to transform biosolids into biosolids derived biochar. And some interesting results have come out in terms of like what actually happens with the heavy metals. They are immobilised by a matrix, and we've done some studies around leaching and so on. But more importantly, like I think even before we were doing some work around biosolids, and we did a 3-year trial just on our ag plots in the campus, and over that trial we found that when we did biomass measurements, heavy metals were not taken up by the plants. So that those important scientific evidence is critical to actually informing legislation or those guidelines. And we also found that that the heavy metals and biosolids are not mobilised until you are applying on soils that are acidic, below sort of pH 4, which we don't have many of. So in the right environment, those materials can still be land applied. So we need to understand the environment and the limitations. But at the same time, there are risks that are happening on current work. So in abattoirs, for those that are not, urban or encroached by housing, they can land apply paunch. There are some abattoirs who rely on bore water, and some of those bore water sources are high in salt, and so by combining that salt or that bore water into the cleaning processes and on the kill floor means that any of the paunch that's applied onto land is high in salt. And some of the testing of soil that we have done in those land apply soils is very sodic. So, even though we think we're doing some good work in land applying organic material, there are those unintended consequences. So we need to be testing and continuing to monitor, and that's one way of understanding the risks and the impacts, whether they're good or bad.
It's really true, isn't it? So we're at the beginning of this journey thinking about systems thinking, applying systems thinking, and how these practices with the evidence we have now can create a risk or an opportunity and how to mitigate it. I guess I'm interested in the regenerating natural systems piece, which you just started to talk about. It's obviously a key pillar in a circular economy framework. So what do we need to do to ensure that we're not just doing no significant harm, but actually going further and thinking about regeneration? You've talked a little bit about the different heavy metals and take up in the right soils and so forth. What other examples can you give us going there?
Yeah, and I think that example of the paunch was leading to that regeneration. I think they're really sort of looking at already what we're doing and how we can make just incremental changes. So I point even to that example of the pork sector and the work that they've been doing for some time, I might say, around biogas capture, is that if it's still around the same, and I would say it would be, 50% of the industry who capture methane only flare, right? And flaring is, okay, you're going to reduce down to CO2, but if you're going to utilise it fully to energy, then that's a further reduction. And I'd say that has come about because, before ERF was CFI, Carbon Farming Initiative, there was a methodology around methane destruction. So the farmers can actually receive AQs for just simply flaring. So there needs to be changes in legislation in order to actually improve the full uptake and therefore emissions reduction. So that's, I think still, I keep on coming back to legislation, because if they are not forced, but rather incentivised to actually do, get money to do the right thing, then they get full regeneration. So that's just an example. I think around, you spoke a lot about methane slip, which I know a lot about as well, mainly from my European colleagues. And they legislate that, I think they're, for I think the Europe guys, 2% slip. So you mentioned a figure of 5%. And they are for those plants that are generating or reducing emissions from waste. It is those 8,500 plants that were established in Germany over a period of time, which actually use energy crops and manure. And so there's been large campaigns across Europe to undertake, measure again how much methane is being, how the fugitive emissions coming from biogas plants, and see how they need to legislate in terms of that reduction. So I'm not sure whether I answered your question.
That's excellent. And we can talk more about that in a sec. We might go to Melita. Melita, what's the role for policy? Because we've just talked a bit about policy, so I thought we'd jump on that in operationalising the circular economy.
Is it working?
Yeah.
Yeah. Okay. Cool. Well, policy is, I guess, extremely important in the sense that when you invest, as you have heard from the speakers, all the technologies involve high capital costs. And whatever pathway we take to have that direction and support from the policy that's been taken on by the governments gives that security, I guess, or that trust that this is the right path, that this is going to be supported, and that the legislation is going to come along that will support and enable a safe operation. I think it's like I can appreciate the value of policy from a recent project that we did, which was basically testing packaging that has been applied in home deliveries. And I could not believe how quickly the merchants and the industry have adopted the compostable packaging compared to the plastic packaging. So that is just like a first-hand example that if you have a policy and you put the regulations, that adoption is actually reasonably fast.
And just building on that then, if we look back, so we've got a lot of organisations, and you've indicated that there is an appetite for change, but to scale, businesses often need security, so they're looking for those policy and regulatory levers, legislation, etc. So what are those sort of important considerations for them? I just want to dive a bit deeper. If you're thinking about the different businesses and organisations coming together, what are sort of the important considerations for them to make that transition at scale to circular economy?
I might step a little bit back in saying what is for businesses really important to understand and consider. So first of all, as we said, we need collaboration, communication, we're all in it. So we are part of this big ecosystem. And for each business, they need to understand the role they have in the ecosystem, which is not a linear any longer. In the future, it's a circular ecosystem, which means that they might have to do things very differently. Quite often, not just replace something with something else, but have a completely different way of thinking. And this has been demonstrated from the new business models that are emerging, some more successful than the others. But the other thing that is extremely important, and every speaker today has spoken about that, is the design. So you really have to put in forefront the design, the thinking in the design. So it's no longer good like, and people who know me, I use all the time this example about whoever invented the coffee cup, who just thought, oh yes, this is like a very short solution, comfortable for us to take. Did not think for a second what's going to happen to that coffee cup at the end. So we cannot afford anymore to think like that. We have to think about the whole value chain, what is going to happen, how you fit in the value chain. You have to also think about not locking a system that it's going to potentially have reverse outcomes. Be more agile in terms of that thinking a little bit more longer term as well. I guess the other thing is to think about benefits beyond the actual solution. So similar to what we're saying about the coffee cup, But in circular economy, we try to not just resolve, like we talk mostly about resources, that's what we understand. And we talk about recycling and how we are going to capture that and stop using the finite resources. But in the nature positive kind of system where it also impacts humans in other ways than just not using, it's how do you feel about things. And water plays, like for water sector, a huge role in that. How do we feel about where we are? And how do we, like it connects us to the nature. It's those things that are important as well.
And what about, we've got a lot of researchers and organisations that work with researchers here at this conference. What are your sort of advice or reflections on the approach to research and collaboration for a circular economy?
Well, definitely collaboration, and never dismiss social scientists, by the way, because I think there is a lot of fundamental scientists. Just as a matter of fact, I used to be a fundamental scientist, and now I would like to call myself a little bit more social scientist. I'm not there yet, but it broke my brain really trying to think in that big picture in the systems, and but we are learning from each other. Like we have, this is what the conference is today about, right? So listen to other perspectives and all those findings that are in like it's a feedback loop, like in a circular economy. So we can't have a legislation without understanding the science. But then again, we need a legislation to limit the science, to not do harm. So it's a little bit of a feedback loop.
Thank you, Melita, for that. And I'm glad to hear not just my brain's exploding from circular economy. It's pretty intense, and it's as big as our whole economy, so we've got to work together on it. And on that note, I'd like to hear from you all. I'm sure you've got some questions for us. I'm not sure, have we got a roving mic to hand people? Oh yes, we do. Fantastic. So whose hand's going up first? Here we are, at the back. Can you introduce yourself, please, and direct your question? It might be to the whole panel, but direct, we've got 15 minutes.
Thank you to all the speakers. And my name's Enrico from Griffith University. Bernadette, you talked about so many things we could do on farms, and this is touching on the previous comment about the social acceptance. How accepting are farmers to change from diesel tractors to other forms? Because that it's a certain culture on farms, and have you looked at that yourself?
Yeah, so adoption or ag-tech adoption is a sort of different form of research which goes beyond just, okay, is a bit of tech going to be functional for them? And it's about, understanding how would they move away from their current practices. Look, diesel, incredibly cheap still in Australia, right? And so until we can actually improve or increase the price, that's going to force them to change. Look, all in general, the farmers who I interact with are really open to accepting new tech. Because all our research is industry driven, we're largely driven by RDC, more RDC funding than ARC, and it's got to come from that Rural Development Corp for which they pay levies into. So they've got to have a seat at the table when they inform which the direction the research will go. So if they've actually got a way of saying, okay, I can improve productivity or profitability by this way, and I want to actually see this tech part of my farming systems, they'll actually get on board. Absolutely, yeah. So from that point of view, they're very positive. And if I have a look at, how we fare as an Australian agricultural sector, it was interesting that case story I put up on around the pork industry in Australia. I actually presented in Cork in Ireland, and I had some pork farmers come to me in the morning tea session and say, we cannot get a return at all of about 18 months, 2 years if we on our return of investment, and they're talking from Ireland's perspective. And when you think about our political or our financial incentives, they're quite low. We Australia in terms of feed-in tariffs and the like. But what we can do, and I'd say is farmerize a system. We're quite well known for our ingenuity and our ability just to get things done that is going to be integrated into that farming system. So I've worked on red meat processing plants, and their core business is, I guess, killing cattle, but they don't even make a profit out of that. And so if they think, okay, production will have to increase by 1,000 headed, then they'll sort of keep on feeding them out, but they're going to remember what happens in the back end with the wastewater treatment. And that's generally an aside, but if they've got biogas capture, they've got to understand that that actually makes money for them, but they tend not to actually look after it. And that's the unfortunate thing, is that they don't actually have the ability to have people to operate it, or knowledgeable people, all the time. So normally they'll have the environmental engineer fixing up a DAF or a pump that's broken down, and that meanwhile all that fats, oils and greases runs into a biogas lagoon, and then basically it can go belly up. But I think by integrating the technology into the farming system and not have it as a side actually helps with that adoption.
Thanks, Bernadette. Another question over here. Please introduce yourself first.
Dharma Hagare from Western Sydney University. Bernadette, you talked about, this is just a comment, Bernadette, you talked about pouch waste. We pouch waste. We have done some trials on pouch waste to use as a chicken feed. We found that there's quite a bit of amino acids in pouch waste, and that could be quite one of the ingredients to produce chicken feed. I guess sometimes with the circular economy, some of these out of the box solutions could be the way to go. Thank you.
Yeah, I think, and paunch has been one of the things that on red meat processing plants, it's an absolute waste. And when you say an absolute, it just hasn't found a way for it. And so for many decades, they've been either land applying when they've had this available space, or or the large processes that are actually house locked, actually landfilling it, which is just terrible waste of a resource. And I think everybody understands that a biomass resource, or any resource, whether it's e-waste, can have multiple uses, and it's about that research, understanding what's the most sensible approach, particularly, and I don't think anybody's talked about this, is about the life cycle assessment around what actually goes into it, and what in terms of emissions. So, and paunch is thankfully been actually looked at probably over the last 5 years, from what I understand. I've worked with it, as I said, for the last 15 years. It is actually getting these new novel ways of being utilised. And so if you can find those amino acids for poultry feed, I think that's fantastic.
Thank you. A question over here.
Thank you, for a very good presentation. So, Michael Duke from Victoria University. My question is for you, actually. So, you mentioned the methane losses. I think 5%. Then it sort of undoes the benefit of having the capture of the biogas and production of energy. But I was looking into this on another topic, and I encountered that you mentioned that the dissolved methane that leaves is actually quite significant, and it's more than 5%. But in terms of low-hanging fruit, I just wanted to give you a comment on that, because you mentioned easy things to do. But to me, when looking at this, the dissolved methane is a little bit trickier. So I just wondered if you can comment if it is a significant amount, and what things being done to deal with it.
Thanks. It's a very good question. So I only emphasize about the low-hanging fruit for the methane leakage part. So first, about this 5%. This is really coming from the literature that I was shown from this survey did in Denmark. So again, it may not be just the 5% in other cases. It's really a conclusion they draw. It's really because the methane, if it's leaked, and with the global warming potential, we have to multiply by that factor. So that's offset with the original fossil carbon. I think that's how that was sort of calculated. In terms of dissolved methane, it is indeed a huge problem. So if you remember my generation of methane from everywhere, so that's the whole wastewater treatment lane is actually, the methane is coming from the dissolved methane, normally coming from two parts. One is the methane generated in underground sewers. During the transportation, there's a lot of methane generated. And then some of the methane already emitted in gravity sewer, where we have gas transfer happened. And then with the rest, when they travel to wastewater treatment plant, they emit it. So what we captured is a minor part of that. So to solve that, we have to look at originally how we can solve to reduce the emission from sewers. That's probably one of the most efficient way. The next part is the return. If we generate any methane, the digest liquor, or if you have a upfront methane generation, USB for anaerobic, then this is also returned back to the main wastewater treatment. So those part of dissolved methane mostly is also stripped out. So those are more difficult than this leakage. So that's a very good question. So
yeah, have you got a suggestion what could be done to capture that dissolved one, the one coming back to the head of the plant? It seems like it's a point source, so maybe there's some ways to degas it, capture it.
yeah, so that's one way. I think people are trying to look at is there better ways that you quickly strip out methane to capture it before it goes to the open surface, so the aeration tank. So that's one way. I think also people try to look at other new technologies, whether methane can be utilized. Some of the, I think, algae and bacteria-based system also can try to reduce or utilize the dissolved methane.
Yeah, thank you. Interesting.
Good question and answer. Okay, we have here and then at the back in the oh, okay.
Thanks. My question is for Joao. I've been doing work around collection of urine, and like you, I've been thinking about how we can incentivize it. And I've been thinking also about something that might sound like a token, and we've been wanting to apply it in different contexts. So, from your perspective, will we ever be able to work around the tendency of human beings of not doing the right thing? Because particularly when it comes to collection of human waste, we don't really have a way to verify they have done it. So what is going to stop people going to the toilet, scanning the QR code so they can get a coffee? I mean, this is really simple, but it will kill it, and it's going to happen, right? Unless we find a way around it.
Thank you. And that's why we've been worrying about and a lot of different approach to the public to convince and to persuade to be part of our activity. So I'm not sure yet. Okay, so that's why we failed. But our project actually got being ripened right now, so to be revived sometime. But we spread our belief and with the courage. So I believe those that believe with courage may be reviving sometimes under different conditions and circumstances. That's why I emphasize on digital culture, digital society. So we have a different value approaching, not only to benefit out of our cost, also willingness to pay. So in business, new business models, so a lot of people actually, they have a willingness to pay more with the special urine toilet and the manure toilet. So I believe their intention sometimes. So only matter of not time and money, but belief and consolidation and solidarity types of company Steve and friends. That's the gave us opportunity. open to everybody. So we should be right now it's negative to all the framework centered around the power intending authorities only focusing so BC types of a business model. That's my opinion.
So you need meters on the toilets, and then you can scan the QR code when you use the toilet, so you can use AI to link the two.
Here's a calibration happening on stage.
Everything is open, I believe, right now.
Okay, yeah, I think we had a question up the back, the gentleman in the white shirt, and then Django, it's you.
Thanks, Lisa. Okay. Yeah, thanks, Lisa, and thank you, panel. It's been so fascinating hearing all these discussions this morning. My name's Ed Wales from Bond University on the Gold Coast. I have a more, perhaps a broader question to the panel in regard to carbon trading. So currently at the international level, we're relying on carbon trading to accelerate our movement to decarbonise the economy. Do you feel that's going to work? Can we achieve this in time? Thank you.
Great question. Who's going to jump in? Give it a go. Come on, the lady, you can go first.
I should go first. It's one of the policy instruments that they could use. In Australia, what happened before, I'd love to believe that, I wish it did work, but yes, I think it should be, if it was my personal opinion, should be one of the ways to accelerate. And again, I guess it goes back to, relating to people, to communities, so they can understand the interaction. So it's like a token, I guess.
With me, as I personally, please do not misunderstand my talking. So with the carbon neutral and carbon trading, so as far as we focus on those activities and within umbrella of economy with the money, I don't agree. So as far as we deal with this one, only material, so I totally agree with this one. So that's my suggestion with my presentation, with many different materials of water and carbon is material, but someone actually wrap it up with different name and different symbols of this. So that's the people actually misunderstood. This is very important within my business, within my activity, within my benefit. So that's my concern. So as far as material is only concern is absolutely a good idea with carbon trade as well. That's my opinion.
Okay, on that note, we might hand over to our last question from Django at City Water.
Thanks very much. Yeah, Django Second, Sydney Water. I've got a comment and a question. I think firstly a comment to Michael regarding dissolved biogas. I just recall a conversation I had with I think a Norwegian or Danish AD company, and it's legislated over there. They have to deal with dissolved methane post AD, and I think they simply put in a tank downstream for for aging and degassing. My question is for Bernadette about biogas done right. A great model on paper. My question is really about the capital hurdles for that type of model, particularly in the farming context. I'm sure there's the big corporate farming context that can, in some cases, take the capital risk on that type of model. But for the smaller scale, potentially, or other applications, I imagine it's a big barrier. I guess the question is, have you seen any good examples of how those barriers of scale and capital risk for the long term are overcome, maybe in Europe? What sort of incentives or policy mechanisms are being used?
Yeah, from what I understand, and I wish I got a little bit closer to my Italian colleague. I unfortunately couldn't make the meeting in Italy, which was a couple of years ago. COVID borders kind of just lifted in Australia. But as I understand, biogas done right represents that concept that the smaller, relatively smaller farming enterprises can adopt something like that. So in Italy, if you can imagine, it's not like Denmark's big cats, you know, the centralised anaerobic digestion systems, which are huge, where that's like a cooperative of farmers, and that's why that works. The big Danish cats work because they have the smaller enterprises, and so perhaps that's in partial answer to your question, that's how smaller companies or enterprises can come on board. But as far as like, it's a bit of a different game really in Europe for AD, because capital is not as big as problem it is here in Australia, and that's why, you know, we adopt the covered anaerobic lagoons, because they're cost effective, because we just simply don't have the feed-in tariffs which will enable us to recover the costs, the gate fees, even the contracts, the lengths for that, you know, when Germany were accelerating their ag biogas plants, you know, they had 20 years. We'd be looking at, if at best, like 1 month contracts for sort of, you know, that you can't be sustainable on that. So, you know, you asked, is there sort of an example, but I think all those little pieces come into play, and biogas done right has the ability to have off-take customers, you know, they're getting premiums on their biomethane going to the grid. They can put it out to the electricity, if they wanted to, even heat that village down the road, because they can. We don't have that requirement for heat in Australia. They also have those integrated in farm practice, and I think one of the things that biogas done right over any other country, from what I've seen, does incorporate all of those other methods of minimum till, precision agriculture. They're looking at the way of fertigation, so that's a real close partnership between the agricultural community and the municipality. And one of the biggest problems we have in Australia is distance. And so even, you know, the regional centres, you know, I've been thinking about what's that blueprint look like for a regional centre since 2015, like nearly 10 years. It doesn't exist yet, although various areas around the country have been looking at it. So, yeah.
Good question, great answer. Can you please join me in thanking our fantastic panel that's given us a lot of really valuable insights. And we have been given the wind up because there's a break awaiting us. So we'll see you after the break, and please feel free to approach this fantastic panel if you have further questions.